Hey students, this is lesson 9.8, Systems of Linear and Quadratic Equations. We're going to learn how to solve systems of equations that may include a quadratic equation with it. Go ahead and do the vocab here and you can check back your answers. All right, so here's our first set of equations, and one way we can solve is by graphing. To graph this system, normally I think when you're gonna graph, you would use a graphing calculator to do this. So I think I'm going to do that. All right, so I put the two equations into my calculator, and now I'm going to press graph. My window now is just a standard window. And I'm looking for where the line is crossing the equation, the parabola. And notice it's crossing it in two places, one place right here, one place right there. To find those places using a graph, to estimate those, we're going to press trace, and then just move the cursor till it gets fairly close to one of those points. Then we're going to press second trace, and choose number 5, which is intersect. And we're going to have to hit enter 3 times, and then the calculator is going to make a guess for us. And we can see that the calculator thinks that point of intersection is -2, 4. So -2, 4 is one point. And the other point of intersection, we're going to press trace again, and then move the cursor to the other side, get it closer to the other point of intersection. Then press second trace, number 5 again, enter 3 times, and 2, 8 is the other point. And so we use our graphing calculator to get these 2 points. Now that we know the points, if you need to sketch a graph of it, so we know -2, 4 is one of the points of intersection, that's right there, and 2, 8 is the other point of intersection. And we can use our calculator to quick make a sketch too. It looks like the vertex there is on -1/2, and it's about up close to 2, something like that. So -1/2, 2, maybe like right about there. And our straight line goes through those 2 points, and then our parabola goes through those, so the graph looks kind of like that. All right? Go ahead and you try this problem. You can check back with the answers. All right, so another way we can solve systems of equations is by using elimination, and I'll show you how that works. We have 2 equations, y equals 24x plus 15 and y equals -x squared plus 120x plus 15. Models the daily sales of 2 types of computers, where x is the number of days since the computers were put on sale. On what day was the same number of each computer sold? So what we need to figure out here is, let me write down the 2 equations. Okay, so what we want to do here is we want to find the value of x and y where these are both the same. To help us do that, if we can eliminate one of the variables, that would certainly be beneficial. And if you look closely here, if I just subtract the bottom equation from the top equation, I will get 0 for y. Y minus y is 0. That works good. Now I have 0x squared right up here now, and I'm going to subtract 1x squared from that. So 0 minus -1 is positive 1x squared. And then I have 24x minus 120. That's minus 96x. And I have 15 minus 15 is 0. So basically I have that. And that, I think the approach to solve that quadratic equation is to factor it. If I factor it, I get x times quantity x minus 96. And so x equals 0 and x equals 96 is our solutions. So the daily sales where the number of computers will be the same is 96. And you probably would want to go back and check that just to make sure. So 24 times 96 plus 15, make sure that equals negative 96 squared plus 120 times 96 plus 15. All right? I'll let you try elimination here, and you can check back with your answer. All right, we can also use substitution to solve these equations, and we'll find the solution here. So we're looking for a value of x and y that make both these equations true. Now notice that y is equal to two things. It's equal to the opposite of x, and it's equal to x squared minus 4x plus 2, which means I can substitute the opposite of x for y, and when I do that, I get this equation. The opposite of x equals x squared minus 4x plus 2. Now to solve that, I think I'll add x to both sides. And then I get 0 equals x squared minus 3x plus 2. And I'm going to see if I can't factor that. So I need two numbers that have a product of 2 and a sum of negative 3, and that would be minus 2 and minus 1. And so x is equal to 1 and x is equal to 2. Works out good for that. Now we have to find the corresponding y values. So when x is 1, we get y is equal to the opposite of x. So x is 1 would mean y is equal to negative 1. When x is equal to 2, y is equal to negative 2. All right? Now remember, another good way to check these solutions would be, since they're both written as y equals, put them in your calculator and check the table, see if you got the right answers. Okay? On this one, we're going to use a graphing calculator to solve this. So we have x squared minus 3x plus 1 and negative 5x plus 1. So x squared minus 3x plus 1, I believe that's what it was. And the other equation was negative 5x plus 1. All right, what we're going to do here is graph it. And hopefully we can see where it crosses. And you can see it crosses somewhere in this area. So we're not seeing it very well, so what we're going to want to do is maybe zoom in closer to that area, and then we can trace and find it. So let's press trace first, and then I'm going to press zoom number 2, which is zoom in. To zoom in, you have to press enter, and that gives us a better picture of what's going on here. And it looks like it just crosses it in one place, at least in this area. So let's go ahead and find that. We're going to press trace, second trace, intersect, enter, enter, enter. And it looks like the point 0, 1 is one solution here. And I think there's probably another solution also. We'll go back to the calculator and try and find that one. And it seems to me that it's higher up, so I'm going to zoom back out. Enter. And it looks like I'm going to trace. Looks like it might cross it somewhere around there. trace. Somewhere up here it's crossing. So I have it zoomed to where I want it, and you can see where the two lines cross right in here. And I'm going to trace that one. And then I'm going to use the intersect button to find where those intersect. And that's the point -211. Now, one other thing you should know, you can go to your table and find that also. And notice here at -2, we have both the y's being equal. So the point -211 is another solution. All right, go ahead, you try this one. Use substitution. All right, last thing, do this lesson check. What you want to do is use two different methods to solve the system and then see which one you like better. So solving it by graphing. So first of all, the equation y equals x, that just looks like that. And then the equation y equals 2x squared plus 10x plus 9. We're going to need some points for that one. So here's some points: -1, 1, -2, -3, -3, -3. That line's right on the line. There's one of the solutions: -4, -1. So we have a parabola that looks like it's going to go something like that. And so there's another solution right there. And that one looks like -1, -1. And -3, -3. All right, so now let's use substitution, see if it works out the same. Since y is equal to x, we can just substitute x for y, and we get this. And then we can put this in standard form. Then we can go ahead and try and factor that. So we need two numbers that have a product of 18 and a sum of 9. Two numbers that have a product of 18 and a sum of 9. So something like 2 and 9 doesn't work. So when I solved it by factoring, I found that the solution was actually x is -1.5. And so what I'm thinking here is when you graph it, you're just getting an estimate of the solution. And so if you really want to get the exact answer, you probably want to use substitution or elimination, or use your graphing calculator. All right, that's the end of the lesson. I'll see you tomorrow.